Hey guys, today we're going to be talking about the differences between acids and bases. This video is going to help you complete the entire digital notebook that we have for this section. So you can see we've got a tab for acids, bases, pH, and the wrap up. First thing that we're going to talk about is acids. So acids have a lot of different things. Yours has just the blanks. I wanted to show you what I have. I want to know about litmus paper. There's these things called indicators. So if you have a liquid in front of you, you need to know if it's an acid or a base without having to taste it or smell it maybe sometimes. So we have indicators called litmus paper that turn a certain color when they're in an acid or a base. There's also cabbage juice that can turn a different color when it's in an acid or a base. So for acids, they are very sour, like your lemons. They are very corrosive to metals. They conduct electricity when in a solution with a pH lower than 7. Okay, so when we have a pH scale, which we'll look at in a minute, anything below 7, so anything from 0 to 7 is an acid. And they produce these H plus ions, acids do. If you were to put an indicator in an acid, such as lemon juice, to tell what it was, it would turn litmus paper red. Cabbage juice would even turn a color, if you poured it into a lemon juice, it would turn a color of a red pink. So some examples are soda, lemon juice, bananas, tomatoes, stomach acid. Okay. Now bases are the opposite. On our pH scale that we'll look at, they are going to be higher than 7. They produce OH minus ions. So think about your cleaning products. These are most of your bases. They're usually slippery like soap. They are very bitter. So bases are bitter when you taste them. So if you were to lick soap or taste something like that was basic, like maybe like a Tums is basic, sometimes they can taste very bitter. But they have bitter taste and they are higher than 7. So the pH scale goes up to 14. So anything above 7 all the way to 14 is a base. If we put bases in a solution and we want to test them with our indicators, they're going to turn litmus paper blue, which is easy to remember because blue and base and bitter, they all start with B's. So they turn things blue. Cabbage juice is going to turn a blue color, and sometimes it'll go yellow, but most of the time, if we're looking at bases, they're going to turn things blue. So some of the examples are oven cleaner, laundry detergent, soap. Okay. So here's our full pH scale from 0 to 14. In the middle, we have neutral. So imagine you have a tug of war. In the middle, you have neutral. Your strongest people are on the outsides. Okay. So the closer we get to 7, neutral, we are going to be weaker. The farther we get away from neutral, we're going to be stronger. So our strongest acids are closest to 0, and our strongest bases are closer to 14. Our weakest acids are right here next to 7 on this side, and our weakest bases are close to 7 on the other side. So if we had to compare and contrast them, I know bananas and lemons, I've already said they're going to be acids. Acids also react with metals, and they are sour, have a lower pH than 7, and turn things red. Bases turn things blue and are slippery, like soap, right here. They are bitter, they don't react with metals, and their pH is above 7. The reason I have here they conduct electricity in water, if you're looking at your pH scale, if they are strong on either end, strong base or a strong acid, they will dissociate and spread apart into ions fully, and they will conduct electricity. So at the bottom, you need to write a compare and contrast summary. So you can use these things to compare and contrast. Although acids and bases both conduct electricity, what do we know about their differences? And then list some of these differences. Okay? When you're done, you can finish turn in, or click turn in.